Hi, thanks for joining us for Phosphorus Science Now. I'm your host, Matt Schultz with the Sustainable Phosphorus Alliance. Soil testing is the way we understand whether we need to add phosphate fertilizer to a crop and how much should be added. Too little phosphorus means plants won't grow and yield optimally. Too much, and fields can bleed excess phosphorus into nearby waterways, causing environmental problems, including harmful algal blooms and greenhouse gas emissions. Now, while you might think that farmers would want to use as little fertilizer as they can to avoid the expense, the fact is that many over-fertilize their crops even when soil tests suggest otherwise. A recent study in agriculture by North Carolina State University graduate student Lily Kyle and her colleagues sheds light on why farmers choose to ignore soil tests and what measures might persuade them to fertilize more appropriately. Well, Lily, thanks so much for joining us for Phosphorus Science Now. This was a great paper, and I'm really excited to have people hear more about what you've done.
Yeah, thanks so much for having me on. I'm so excited to share some of the findings that we have from this paper. So a little bit about what it's about. So the purpose of the study was to assess grower behavior with respect to proper application of phosphorus, right? Because that's one more avenue for exploration into efficient use of phosphorus. And so this study was based on data that was analyzed from a survey that we conducted in North Carolina, where we asked 122 farmers to respond to some questions about soil sampling, their soil phosphorus levels, and decision making to help provide some insight as to how likely growers are to follow soil test recommendations. So, some of the questions that this paper is going to answer include what are farmers reporting their soil phosphorus levels to be, how likely growers are to follow soil test recommendations, and something I'm really interested in is why does overapplication occur? Also, a little bit about how price influences phosphorus fertilizer decisions. So, if any of these questions intrigue you, keep listening, and I'm going to answer all of them in the next 10 minutes.
All right, that's great. So maybe you could tell us a little bit about your collaborators and who funded this work.
Yeah, so answering these questions converge on the boundary of many different fields of study, right? These questions involve farmer psychology, economics, soil science, sociology, chemistry, behavioral studies, all to try to better understand what the challenges may be to utilizing this precious resource most efficiently. So we put this team together. Dr. Luke Addaboni, who is my advisor here, and he's in soil fertility. Deanna Osmond, she was at NC State for decades working on this particular topic of working with growers to reduce their phosphorus usage. We have Dr. Anna Maria Marshall, who is a sociologist at University of Illinois, so providing some of that farmer psychology aspect to the paper. Dr. Amy Johnson, who's worked with phosphorus in North Carolina as well, and Dr. Owen Duckworth, who is a soil phosphorus chemist. So we put this dream team together to help try to answer some of these fascinating questions that really require these multiple areas of expertise.
That's great. And this was all funded by the STEP Center, which we're all part
Yes, it
of.
was funded by STEPS. I am a student funded by STEPS.
Excellent. Yeah, yeah. Great. Okay, well, why don't you just walk us through what you found?
Great. So, we ended up coming up with this survey to send to North Carolina growers, and most of the participants were on larger farms growing row crops. Now, when I get into some of the questions that we asked them, I want you to go in with a little bit of background on what over application means when I say over application. So we're all on the same page. So this diagram here, um, it shows plant response to a nutrient. So let's say on the y-axis, we have increasing levels of phosphorus, and on the y-axis is the plant response in yield. So you're seeing diminishing returns for each additional unit applied. So at first, if you have a very low amount of the nutrient and you apply a little bit, you're going to see huge yield jumps. And as you continue to apply more, you see diminishing returns until you hit something that we call the critical level, which is where the green arrow is pointed to. And so that is where you maximize yields without before you end up, seeing any diminishing returns. So anything before that critical level you would have a yield loss due to fertility issues, right? Not enough nutrients to maximize yields. But anything above that, indicated in the orange bar, would be a reduction in farmer profit because they're applying more fertilizer than is being used by plants, right? A waste of our finite resources and the potential for pollution. So we want to be right where that green arrow is. That's the most efficient place to be. So how do we know what the right level of phosphorus is? We don't always know exactly. There's a lot of factors at play, right? Like there's a variation in soil types, whether varieties grown. But what we do know is that we have extensive research that does try to find this optimal number. A lot of people have worked on this for many years in many different locations. And in North Carolina, we have long-term sites dedicated to this. So, okay, given all this background on what this means, where do you think the soils of North Carolina growers are on this diagram? Are they losing yields due to lack of fertility in that purple range?
I'm gonna
Or
guess they're in the orange range.
are they losing profits due to waste in the orange range? Well, we asked them just that. And so their self-reported soil test phosphorus levels came to be high and very high, you can see in the diagram. And that puts a lot of the soils above the critical level, right? That means we're in reduction in farmer profit territory, waste of resource territory, and pollution. So this is not efficient. So I want to know, okay, why is this happening? Is it due to lack of knowledge on phosphorus levels in their soil? Maybe farmers just don't know, right? So we asked farmers, okay, how often do you soil sample? And the answer is quite often. So 99% of farmers were sampling as much or more often than is recommended even. So we know these high phosphorus levels are not due to lack of soil sampling. Okay, so that's great. Farmers are soil sampling. That
And
means they're, go ahead.
sorry to interrupt you, Lily. Can I just ask you, are these farmers doing precision application or are they just doing run-of-the-mill application?
Yeah, so we that was actually a question we asked on the survey and didn't even include in the paper, but about a third of them were doing precision. Some of them were doing, zone and traditional as well. So you get a mix of a lot of the different. But yeah, quite a few were using precision agriculture.
Thanks.
Yeah. So that's how they're sampling. And they're getting their recommendations from about half from the NCDA and half from other labs, but they are receiving recommendations. But what are they doing with those recommendations? Are they following them? So we asked them, okay, do you follow the phosphorus recommendations on the soil test report? And 58% of farmers are saying that they change the rate recommended by the NCDA soil test report. So over half are intentionally not following the recommendations.
And just to clarify, NCDA is North Carolina Department of Agriculture, right?
Yes, yes, thank you for that clarification. Yeah, so those are so recommendations when farmers soil sample and they send in their samples. If they send it to the NCDA, they get back recommendations based on what their soil test value is, right? I think other labs do the same thing as well, but they might come back with different numbers. It really depends on where, but at least half of them indicated they soil sample at the NCDA because it is free for growers. So a lot of them do it here. But depending on what state you're in, that is going to vary. But usually it's subsidized and pretty cheap for farmers to go through their state. Um, so yeah, they a lot of them are not even following what the recommendations are. And I asked a follow-up question. So if the soil test report indicates you have enough soil phosphorus, what are you going to do? And 64% of farmers say they're still going to apply more, even when the soil test report says that they have enough. And what 36% say they're applying the maximum rate I even gave them an option for. So this is a really big problem. But we want to know why is this occurring? Like, why are they adding more on top of this recommended rate that's backed by research. So here's what we think is happening. Farmers are faced with the question, how much of a nutrient should they apply, right? They want to get this critical level right, which is, I guess, a mystery for them, right? Um, so when it comes to a recommended body, determining what that critical level is, a lot of research goes into it. They're not guessing blind. But of course, research has its limitations, right? There's some variables that cause differences. Like you could have variation in soil type, right? Different varieties grown. There's a lot of factors. So recommending bodies need to add a buffer to what they think this number is because they do not want to underguess, causing farmers to lose money due to fertility issues, right? So they'd rather overguess just a little bit. So they add a buffer, a little extra, just in case. And then they give that number to farmers. And what do farmers do with it? They add another buffer. Remember from the last slide, they say they're going to apply a little bit more. So farmers are operating on really low margins. They can't afford to be losing yields by underguessing fertilizer needs, right? There's so many variables in farming, there's that they can't control, like weather, all sorts of the price of grain, all sorts of things. But one thing that they can control is not losing yields due to lack of fertility. And so they're going to add a buffer on top of that. But unfortunately, that buffer puts them in this range, the reduction in profit, a waste of resources, and potential for pollution. So this is inefficient. It's inefficient for farmers. They're not benefiting by doing this. I was also really interested in if price would affect their decisions. So we asked them in 2022, the prices of fertilizer skyrocketed. Did you reduce the phosphorus that you used? And a lot of them did not change anything. And this is really relevant when talking about solutions to these problems, is a lot of people sometimes will say, oh, we should add a tax, a Pagovian tax, which is a tax used to correct market inefficiencies, right? And this works when there's a price sensitive good, right? There's going to be, let's say, an elastic demand. But if something has an inelastic demand, meaning nobody's changing what they're doing, based on price differences, then this tax is not going to work. This corrective tax is ineffective. We asked them, how are prices going to change your phosphorus applications, just to give them a chance to, short answer, speak their mind. And some of the responses were really interesting. They said, gotta have fertility to have the crop. They're going to apply what is needed, change it very little. Probably not going to change it. You have to keep the levels correct. Cutting out phosphorus cuts out yield. Prices won't affect my decision. So a lot of them, I mean, if this really backs up, I think a lot of what we were saying before, that we are seeing compounding conservatism. They're going to make sure that they're not losing any yields due to fertilizer, and they're going to keep applying. So a corrective tax might not be an effective solution. I think a more preferred set of solution would require voluntary measures. So encouraging farmers to apply phosphorus at the recommended rates. There's really a potential benefit to extension services provided by the state, and I go more into this if you read the paper. But a lot of times they're overlooked and they're mistaken for not being a service with ties to profit, right? But there may be major economic and environmental benefits hidden in that a state receives from investing in extension services. So in current times where budgets are being looked at the federal level and at the state level, and they're trying to cut, I just really want to encourage those in decision-making positions to reflect on these hidden benefits that extension services provide. We have these grand challenges in regards to phosphorus resource conservation, and we're seeing major economic inefficiencies as a result. Phosphorus is being applied at a rate that is beyond what is beneficial for both farmers and the environment. And this has led to a waste of our precious finite resources, a reduction in profits, and environmental damage. So, this topic is really important as growers are operating on a small margin to provide us with food at a low cost. So, this is an issue, yeah, we're seeing in North Carolina, but other states may be seeing it as well. So my desire is really just to see phosphorus applied at a rate that's closer to the perfect level, that critical level where yields are not sacrificed, but neither is our resources. And if we can get there, it's an everybody wins scenario. So one thing I just want to encourage you, anyone who's listening, that you can do is just to continue our collaborations to work towards finding and implementing the right fertilizer rates.
Well, that's a great message, Lily, and it's a really nice paper. So thanks. I certainly encourage people to look it up and read it if they can get a hold of it. And I want to thank you again for taking the time, sorry, taking the time to talk to us.
Yeah, thanks so much for having me. Do you
All
have
right.
any questions?
No, I think that pretty much covers it for now. Thanks.
All right, great.